Good morning, guys. Welcome back. So today we're going to be discovering the area of a circle for section 11.2. Before we get into using the area and specifically finding the areas of sectors, I wanted to do an exploration. So this is a sheet that it has 1, 2, 3, 4, 5, 6, 7. It has 8 pieces. You would cut all 8 pieces of the circle on the left hand side or the right hand side, and you would rearrange them to form a shape similar to a parallelogram. You would use the formula of the area of a parallelogram to derive the formula for the circle. So the really cool thing about this is, sometimes, most of you guys might already know, the area of a circle, but this is just to really figure out why it is and be able to see in person exactly with the pieces how it works. So what I did is in class I would have obviously given you this and you would work with your partner. So what I'm gonna do is I have this sheet and I already cut up all the pieces and I numbered them. And so the goal here would be for me to assemble them again like a parallelogram. So I have all my pieces, and after struggling for a bit, I have created something like this. Move this one up. Oh, not this way. And then this last piece would go right over here. Okay, so it's not perfect, but we get the idea. So the thing is, we have this parallelogram, right? Ideally, you would have this straight shape that would look as like the following one that I'm about to draw. Something like that. So we know that the area of a parallelogram is the base times the height. We know that, right? So in this case, we're going to be using the same format, but now modifying it based on the parts that we're working with, because we do have to remember and keep in mind that these are parts of a circle. So for example, this length right here, right, it's the radius right here. This is the radius of a circle. And then these outer parts are all what make up the circumference of the entire circle when they are put together. So the first thing first is I'm going to go ahead and actually move this up a little bit. Okay, so I have my pieces here. As you can see right there. And I'm going to go ahead and do what I said I was going to be doing. So we have the area equals base times height. Now, I know the height of this whole thing would be this portion here, from here to here. And I know that that is the radius, right? So that is just the radius. So area equals base times the radius. So now I need to figure out what the base is. Well, the base is this entire part right here. Well, I know that if I were to have combined all of this, it makes up the entire circumference of the circle. Keep in mind, so I know that the circumference, when I am dealing with it in terms of radius, it's 2 pi r. But again, I'm only looking at half of it. So I'm going to have to divide by 2 if I'm only looking at these outer arcs. And that would give me pi r. So the base here is all just pi r. So I'm going to go ahead and substitute that in right over here for the base. So I have pi r times r and then when I multiply everything together, I get pi r squared. And that is the area of the circle. So I think it's really fun, really interesting to just be able to play around with these things and just see how it all works together. It's also just more fun, in my opinion, to work with these rather than just be given the formula and move on. These are really some interesting and cool things that happen when you are working with circles, and yeah, I'm really sad that we don't get to work with this in class, but again, it's something that I think you would have enjoyed definitely a lot. And so then now we're going to finally move on to the actual 11.2, and we will begin those sets of problems.